Hello and welcome to our lesson on exponent rules for polynomials. And specifically the polynomials that we're going to be looking at today are going to be monomials. That means these polynomials will contain single terms. And the exponent rules that we're going to discuss are the rules that we apply when we multiply two monomials, or what are the rules that we apply when we divide two monomials, or when we raise a monomial to a power. What happens with our exponents? Now, technically the rules that we're going to talk about we don't need to know. They're technically going to be shortcut processes for us, but believe me, these shortcuts are going to come in handy, and hopefully they'll make a little bit of sense, so it won't be a lot of memorization because it'll be a little bit intuitive. Okay, now before we get into the rules, there's some vocab that we have to understand. When we're looking at a polynomial expression, like the one I have here, this 5x to the fourth, there are three components to that expression that have different titles. So the number that's sitting in front of the variable, the 5, the number that's sitting in front of the variable, we call that a coefficient. So in this expression, in this monomial expression, the 5 is the coefficient. Okay, that's what we call a number that sits in front of a variable. And then here, the variable itself, yes, is a variable, but because it has this power of 4 here, we're going to call it the base of that power. So the variable is the base of the power, and then I've already said it twice here, but 4 we can call an exponent or a power. So that's a superscripted number. That means it's written a little higher and a little smaller, but we call that an exponent. So we could say that x has an exponent of 4, or we can call it a power, so we can say x is being raised to the 4th power. Okay, so when I talk about coefficients, I'm talking about the number that sits in front of the variable. When I talk about bases, I'm talking about the thing that's being raised to the exponent or the power. Okay, so what are the rules for simplifying? The first rule for simplifying we're going to talk about is called let's get the pen going here, the product rule. So what rule do I apply to exponents when I am multiplying two polynomials? So product means multiply. So let me take you off the note sheet for a second here. Let's say I asked you to multiply x to the third and x to the fourth. Well, if we think about what's really happening here, right, x to the third means x is being multiplied by itself 3 times, and then I want to multiply that by x to the fourth, which means x is being multiplied by itself 4 times. So really what's happening all together is x is being multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. So I could take this and rewrite it as x to the 7th power. So this expression would simplify to x to the 7th power. Now, writing it all out like this, expanding it out, is sort of a long way to go about figuring out that answer. Is there a faster way to get from this exponent of 3 and this exponent of 4 to our answer here, our simplified answer, which was 7? Of course, you're all seeing this and you're saying, yeah, we can just add those, right? The 3 plus the 4 is going to get us to that 7. So the product rule is going to tell us to add our exponents. That is the shortcut for this process. So the product happens, just where does it happen? Where does the multiplying actually happen? Right, so we're multiplying these two expressions, but we're actually adding exponents. Well, multiplication is happening, we just don't see it. It's happening with these coefficients. But the coefficient here is 1, and the coefficient here is 1, and 1 times 1 is still a 1, so we don't see it happen. Now, if we made those coefficients other numbers, let's say that this was a 2 here, and let's say this was a 3 here, then we would still multiply those coefficients. So the 2 in the front here and the 3 in the front here would put a 6 in the front here, and then the addition is going to happen with the power. Okay, so that is the product rule. It says to multiply coefficients to get this new product here, and then add the exponents, and that's how we got the new exponent here. Okay, so the product rule, again, this is when your monomials are being multiplied. When you are multiplying two monomials, it states that we are really just going to multiply the coefficients. Multiply those coefficients. What we do with the exponents is we add them. And we're going to be adding exponents that have like bases. So I can add x's with other x's, or y's with other y's, or z's with other z's, etc. Okay, so x to the third times x to the fifth is going to be x to the 3 plus 5, which is 8 altogether. And then here, if we have coefficients that are other than 1, the 3 gets multiplied by the 2 to make 6. X to the 4 gets added to the 5, and that makes 9 altogether. So 6x to the 9th would be our simplified form. Okay? So there's our product rule. Product rule says multiply and add. Multiply and add. Okay? The next rule we're going to look at is called the quotient rule. Do you know what quotient means? So quotient is division. And it should make sense that what's going to happen here is the exact opposite of what happened in the last one. Multiply and divide are opposites, right? So what happens when we divide? Well, let's look at another example off the note sheet here. If I had x to the 5th over x to the 2nd, think about what's happening. On the top of the fraction, x to the 5th means 1, 2, 3, 4. X is being multiplied by itself 5 times. On the bottom, x is being multiplied by itself twice. Now, when we have a fraction with things in common to the numerator and denominator, what can we do? Well, if we have common things in the numerator and denominator, we can reduce those out. So 2 of the x's will reduce out, and what does that leave us? It leaves us x to the 1, 2, 3, x to the 3rd power in our numerator. Well, it's technically x to the 3rd over 1, but we don't need the 1 at the bottom of the fraction. So our answer, our simplified form, becomes x to the 3rd. Now again, writing it all out here, expanding this out, that's a little more work than I want to do. So what's the quicker way to get from the exponent of 5 and the exponent of 2 to our new exponent of 3? Well, again, the opposite of what we did before. Instead of adding when we multiply, we're going to subtract when we divide. And the division is happening again with the coefficients. So a coefficient of 1 here and a coefficient of 1 here, 1 divided by 1 still gives us a coefficient of 1 here. But if we change that, let's say our coefficient was 10 here, and let's say our coefficient was 5 here. Well, then we're going to divide those coefficients, so 10 divided by the 5 would give us a 2 in front here. So it's the exact opposite of what we had in the product rule. Instead of multiply coefficients and add exponents, we're going to divide coefficients and subtract exponents. So this is going to be applied when we are dividing. When our monomials are being divided, it states to divide the coefficients and subtract the exponents. And again, we're going to be able to subtract exponents for like bases. So here, x to the 12th over x to the 4th becomes x to the 8th power. 12 minus 4 is 8. And then here, we've got a negative out in front. That's just going to stay out in front. And then we'll divide the coefficients. So 18 divided by 3 makes 6. And then we're going to subtract our exponents for like bases. So 12x's here minus the 4 on the bottom leaves me 8x's. And then for the y's, 6 here minus the 1 on the bottom is going to leave me y to the 5th. Okay, so negative 6x to the 8th, y to the 5th becomes our answer. Alright, so not so bad so far. We got 2 down, 3 to go. The next rule we're going to look at is called the power rule. And the power rule is going to be applied when we're raising a power to another power. So it's taking, a monomial expression and raising it to another power. So you got a power to a power. What's going to happen here? Again, let me deviate for you here. X to the 5th to the 3rd, for example, what happens? Well, to the 3rd power means I'm going to take this base and multiply it by itself 3 times. So this really means x to the 5th times x to the 5th times x to the 5th. Well, we just saw before in our product rule that I can now just add these and get to x to the 15th altogether. But I don't want to have to write this out. I don't want to have to expand it. That's the longer way to do this. So again, what is the quicker way to get from our exponent of 5 and our exponent of 3 to our answer here, which was 15? Well, in this case, we're just going to multiply. So multiply, that's the shortcut here. But again, we got to be a little more careful with the coefficients. So the coefficient of 1, not affected in this problem, 1 times 1 times 1, we still have a 1 here. When our coefficient is something other than 1, what we want to make sure we do is raise it to the power that's on the outside as well. So we're going to multiply not only this exponent, but everything has an exponent. So this 2 technically has an exponent of 1, and we want to multiply that one as well. So what we're looking at here is a 2, the coefficient of 2 being raised to the 3 times 1, which is the 3rd power, and an x to the 3 times 5, which is the 15th power. So 2 to the 3rd power becomes an 8 for our answer, so 8x to the 15th. And that should make sense, right? If I stuck a 2 here in front, same problem that we have here, then there'd be a 2 here, and a 2 here, and a 2 here, and 2 times 2 times 2 is going to be 8. and that's also 2 raised to the 3rd power. Okay? So we've got to be a little more with those, careful with those coefficients that aren't 1, but our power rule says to multiply all exponents. We just have to make sure everything has an exponent. So if I had, let's say, 3xy squared all to the 4th power, then in the parentheses here I need to recognize this has an exponent of 1, this has an exponent of 1, and of course here we have an exponent of 2. So all 3 of those would be multiplied by 4. So you'd be looking at 3 to the 4th, x to the 4th, and then y to the 8th. And then 3 to the 4th we would simplify and continue to get our answer. Okay? So this is our power rule. Applies when you're raising a power to a, oops, I erased my word here. A power to a power. And it's telling us to multiply all of our exponents. Okay, just remember everything has an exponent. So we multiply here, this becomes x to the 14th. And then the 5 has an exponent of 1, so we want to multiply that and multiply that. So we've got 5 to the 1 times 2 is 2, and x to the 4 times 2 is 8. And then we go one more step here because 5 squared has a value. 5 squared is going to be 25, so 25x to the 8th power becomes our answer. Okay? So those are the ones I think are pretty straightforward. And actually the next one is the easiest of the rules. It's called our 0 rule. Because we aren't generally allowed to leave 0 as an exponent because there is a simpler form for a 0 exponent. And let me just show you. Let's say we were looking at something like x to the 5th over x to the 5th. If I use the subtract rule that I showed you a second ago, well, 5 minus 5 would be 0, so we'd end up with x to the 0 power. But we don't want to leave a power of 0 because there is a simpler form for that. Technically, what happens when what do you get when you divide something by itself? Like if I said take 5 and divide it by 5, well that's 1. Or 10 divided by 10, well that's 1. Or 27 divided by 27, right? That's going to be 1. Anytime you divide something by itself, you get 1 as a result. So the same thing is happening here. If I take x to the 5th and divide it by itself, x to the 5th, the result is 1. So I used the subtract rule to get x to the 0. I used just division, right, dividing anything by itself to get a result of 1. It's two different approaches, and the two answers look different, but they're both correct, which means that these are equivalent. Okay, and that's basically our 0 rule. Anything raised to the power of 0 is going to be equal to 1. Because if we ended up with a power of 0, it's because we had the same exponent on the top and the bottom. So anything raised to the power of 0 is 1. That's the easiest rule. Anything raised to the power of 0 is equal to 1. So if I take 9x, this entire quantity, and raise it to the power of 0, then the entire quantity becomes a 1. Or if I take the number 12 and I raise it to the power of 0, the entire quantity becomes 1. Now be careful. If I take the parentheses away, then the 0 here in the first problem, it applies to the entire quantity. In this next example, the 0 only applies to the x, not to the 9. The 9 has its own exponent of 1. So here, this 9 doesn't change. It's still going to have an exponent of 1, but the x to the 0 portion, this piece, becomes a 1. So instead of 9 times x to the 0, it becomes 9 times 1. Well, 9 times 1 is just 9. Okay? And it would be similar if we had, instead of 12 to 0, let's say we had negative 12 to the 0. In this case, the 0 again only applies to the 12, not to the negative. So this would be a negative times 12 to the 0 becomes a 1, so the result would be a negative 1. And if I put parentheses in it, if I put negative 12 in the parentheses to the 0, then the entire quantity is raised to the 0, then the entire quantity becomes a 1. Okay, so make sure you're differentiating here. I threw a lot of extra examples in there. It's the simplest rule, but it's also one where we could make the most mistakes. Make sure that the only thing that becomes a 1 is the base of the 0. Okay, only the thing that's being raised to the power of 0 becomes a 1. So if the 0 doesn't apply to an entire quantity, then the entire quantity won't just become a 1. Okay? The last rule we're going to look at, I think, is the one that trips people up the most. This is the negative rule. Just like we aren't allowed to leave 0 as an exponent because it has a simpler form, we aren't allowed to leave negative exponents because they have more proper forms. So how do we end up with a negative exponent, and what do we do? Let me show you again here. If I was to use my subtract rule would say, okay, 3 minus 5, that's going to leave me a negative 2. Well, that's no good, okay? No good to leave a negative 2. But what is that negative 2, or how do we fix the negative 2? How can we rewrite that? Well, think about this the other way, right? When I showed you the quotient rule before. X to the third means I have x being multiplied by itself 3 times in the top, and then 5 times in the bottom. So again, I have things in common here that I could reduce. If I reduce those things out, what do I have left? Well, what I have left is an x squared, but it's on the bottom of the fraction. Technically, what's left on the top? Well, the coefficient of 1 is left in the top, so 1 over x squared. So I used my subtract rule to get this as an answer. I just divided and reduced to get this as an answer. Okay, they look a little different. They were different approaches, but they're both correct, which means they are equivalent. So x to the negative second power is the same thing as 1 over x to the positive second power. Okay? What a negative exponent is telling us is that the base of that exponent is on the wrong side of the fraction. So when I subtracted 3 minus 5 and got x to the negative 2, technically that's x to the negative 2 over a positive 1. That negative is telling me that those x's should have been on the bottom of the fraction, and that's what I can see here, right? There were 5 on the bottom, so that's where the 2 leftovers should have stayed. So anything with a negative exponent is on the wrong side of the fraction. So when we see a negative exponent, a base with a negative exponent, all we have to do to fix it is move it. Alright, so if you had, let's say, 5 over 3x to the negative fourth, okay, this base has a negative exponent. That's the only one, right? The 3 has a positive exponent, so does the 5, but the base doesn't. So that's telling me these x's, they were supposed to be up here. So I wouldn't move the 5, I wouldn't move the 3, but the x would go to the top so that those exponent, or the exponent of 4 can become a positive. It's supposed to be on the top of the fraction. So a negative exponent tells me that that base is on the wrong side of the fraction. Anytime you see a negative exponent, you move that base to the other side of the fraction and make that exponent positive. Okay? Oops. So here, any part of the expression with a negative power moves. You're just going to move it to the opposite side of the fraction to make the power positive. So again here, the 2 has a positive 1 for an exponent, the 3 has a positive 1 for an exponent, which means the 2 wouldn't move and the 3 wouldn't move. But these x's belong here. They're supposed to be on the top of the fraction so we can make it positive. Okay, or here, the 8 has a positive exponent, but the x doesn't. So right now, the 8's on the top of the fraction. It needs to stay there. The x needs to go to the bottom so that we can make that a positive 3 for its power. Okay? So those are the 5 rules, and I think one at a time they're not so bad. But we have to be able to combine these rules within one problem and still end up with a simplified form for our polynomial. So just one thing before we get to combining the rules. We got to be really careful with addition and subtraction. Notice in the list we put on the front there, we didn't have any rules for addition or subtraction. So like a 3x squared and we add it to a 4x squared, okay? When we're adding and subtracting, that's a different thing. We're combining like terms. We're not changing any exponents. So a 3x squared plus a 4x squared, that's just a 7x squared, right? We don't change the exponents there. So exponents do not change with addition or subtraction. And similarly with the next problem, the 8x squared minus the 2x, those aren't like terms. I can't do any subtraction there. I wouldn't change those exponents. This would just stay as is, x squared minus 2x. So adding and subtracting, we don't change exponents. We try to simplify by combining like terms. All right. So now, let's look at putting multiplication, division, the power rule, possibly some negatives and some zeros all in to some problems to combine those rules. In general, when we're combining rules, we want to follow our order of operations. So we would work inside of parentheses first. If we had something to simplify in any set of parentheses, try to do that. And then if we have any exponents outside of parentheses, any powers outside of exponents or outside of parentheses, we try to take care of those. Then we would do any multiplier dividing rules. And then addition and subtraction, we're not going to see that here, so we don't really have to worry about these last two steps. But, just so you can kind of follow that as a guideline. And then, again, simplified polynomials should not contain negative or zero exponents. So negative exponents or zero exponents, all right, because those have simpler forms. So let's look at the first problem. Hopefully you're seeing two rules in this problem. So I see a power rule here. We've got powers in the first set of parentheses being raised to the power of 2. And then I also see product here. These things are being multiplied. So what has to happen first? Well, according to our order of operations, okay, let me just again use this as a guide. I don't have anything inside of this parentheses to simplify. I don't have anything inside of this parentheses to simplify. So I'm going to go here to exponents. I'm going to use my power rule first. So the power rule says multiply all of my exponents. So all of these are going to be multiplied by 2. So that's going to give me a 2 squared, an x squared, and a y to the 4th. And so that's my first set of parentheses now. The second set I'm just going to bring down. So I'm just going to bring down 3x squared y cubed. Now before I actually apply the product rule, I want to fix... Wow, that highlighter is ginormous. I want to fix that... coefficient. 2 squared has a value, so I'm going to make that 2 squared a 4. So 4x squared y to the 4th is now going to be multiplied by 3x squared y to the 3rd. So we're multiplying our coefficients. The 4 times the 3 is going to give me a 12, and then we're going to add our exponents for like bases. So if I'm looking at the x's, make this smaller. I've got 2 x's here and 2 x's here, which is going to give me 4 altogether. And then if I look at my y's, I have 4 y's here, 3 y's here, which is 7 of those all together. Okay? So that's it. 12x to the 4th, y to the 7 is our simplified form of that product. Okay? Number 2 is pretty similar. I see a power rule on the top, and then there's obviously quotient rule in here, but exponents have to happen before division. So let's take care of that power rule on the top. All of these exponents on the top are going to be multiplied by 2. So 3 squared, a to the 4th, b squared. So we have 3 squared, a to the 4th, b squared on the top in the numerator. And then we still have our 3ab cubed in our denominator. And just like the last one, I want to fix this coefficient. That 3 squared is really a 9. So I'm going to make this a 9 here. And now I can use my quotient rule. So I'm going to divide. If I divide these coefficients, the 9 divided by 3 is going to give me a new coefficient of 3. And then I'm going to subtract my exponents. So I have 4 a's on the top, 1 on the bottom. And those 4 minus that 1 is going to leave me a to the 3rd power. And then b to the, let's see, I've got 2 here, and I'm going to subtract out 3 here. Let me see if I can get a different color since I already used that one. 2 here minus 3 here is going to give me a negative 1. Now remember, polynomials aren't supposed to be left with negative exponents. Why do I have a negative 1 as an exponent on b? Because if I had 2 b's on the top of the fraction and then 3 on the bottom, when 2 of them reduced, where should the 1 left over have been? Well, it should have stayed on the bottom. So that negative again is telling me that that b is on the wrong side of the fraction. So I'm going to leave the 3 and the a cubed on the top because they have positive exponents. I'm going to move the b to the bottom so that the exponent becomes a positive 1. And that's going to be the most simplified form of that answer. Okay, so there's that guy. And I guess I should box this one in over here as well. Alright, let's look at number 3. Number 3, it looks like a quotient rule in here, but I can't really divide anything in the parentheses because none of those bases are like bases, so I can't do that. Now I have 2 rules occurring at the same time here. That is a power rule, but that's also a negative. So the negative rule doesn't really go into our order of operations, so you can take care of the negative whenever you want. You can do it first, you can do it last. In general, for me, I try to take care of the negatives first because they tend to be the ones that get mistaken the most. So if we can eliminate the negatives right out of the gate, maybe that's a good idea. So I would try to take care of the negative first. Now, what does the negative tell us? Well, it tells us that the bases are on the wrong side of the fraction, right? So if this negative exponent applies to this entire fraction, it means that everything in the fraction is on the wrong side of the fraction. So everything from the top should go to the bottom, and everything from the bottom should go to the top. That way we can make that exponent positive. So everything in the parentheses is raised to a negative, which means everything in the parentheses has to move. So we're going to start by flipping this fraction. R to the fourth goes to the top, and then 4pq to the fifth goes to the bottom, so that we can make this a positive 3. Okay, now we can use our power rule. And the power rule, oops, go away calculator. The power rule says multiply all of our exponents. So we got an exponent here. We're going to multiply that one, that one, that one, and that guy. So we're going to have r to the 4 times 3 is 12 on the top, and then 4 to the 1 times 3 is 3 on the bottom. P to the 1 times 3 is 3, and Q to the 5 times 3 is 15. Okay, and now just one last step. I want to fix this coefficient. So our final answer is going to be r to the 12th on the top, and then 64, p to the third, q to the 15th on the bottom. And if you aren't sure how to use your calculator to figure out the value of, let's just say, that 4 cubed, Desmos, I can't remember if I've showed you Desmos, yet this might be the first time. So in the First Things First module, I said to either download the app or access Desmos at desmos.com. It's a free graphing calculator app. So it looks like this when you open it up on your phone or if you open up the website. And 4 to the third power, if you want to evaluate that, you would put in 4, and then you're going to use the A-B button here. So use that A-B button to get to an exponent, and then an exponent of 3, and then it tells me that 4 to the third power, it makes 64. Okay? So if you want to use your calculator to evaluate some of those coefficients, you're welcome to. Alright, so here's a good one. I think if you're feeling pretty confident about this might be a good spot for you to pause the video and try number 4. But obviously I can't force you to do that. So if you want to pause it, try, and then come back and see if you did it right. Awesome. If not, let's see what's going on here. So we've got two rules. We've got these things being multiplied, that's product. But we also have a power with a negative. And I would, meant to do highlighter, I would get rid of that negative first. So if that negative exponent applies to everything here, that means all of this stuff belongs on the bottom of the fraction. Right now, this is all over 1. So I want to take that whole thing, that quantity, and move it to the bottom so I can make that to a positive. So I'm going to leave the 4, p to the third, q to the fourth on the top. I'm going to take the 2pq cubed, move it to the bottom so that that exponent becomes a positive. Okay. Next, exponents have to happen before we can do our division. So I'm going to use my power rule on the bottom. So multiply, I wanted to change that. Let's multiply each of these exponents by 2. So that's going to leave me the same thing on the top. Just going to bring down my 4p cubed, q to the fourth. On the bottom, we've got a 2 squared, a p squared, and q to the sixth. And then this 2 squared becomes a 4. Hopefully we're okay with that. And now we can divide. Let me just change the color. Let's make this 4. Okay, so now we can divide. Use our quotient rule, which says to divide the coefficients and subtract the exponents. So the 4 divided by the 4 is going to leave me a 1, which I don't have to write, but I can. And then I'm going to have p to the, let's see here, we've got 3 p's minus those 2, so p to the first. And then q to the 4 minus 6, which is going to be a negative 2. And negative exponents, again, not going to be allowed. So that q, that's the base of that negative, is on the wrong side of the fraction. Again, think about here, right? If I have 4 of these guys on the top, and I have 1, 2, 3, 4, 5, 6 of them on the bottom, when those 4 reduce, the 2 left over were supposed to be on the bottom of that fraction. Okay? So the 1p to the first can stay on the top, and I'm not going to put the 1 there. If you want to put the 1, you can. I probably wouldn't put the 1 there either. Well, let me leave it for now, and then I'll show you again. But the q needs to go to the bottom so that it's positive. Its negative 2 can become a positive 2. or if you just wanted to write this as p over q squared, you don't have to put the exponent of 1 or the coefficient of 1. Okay? And there's that guy. Another one, if you feel good, got the last one right, or maybe you didn't, you want to try again, feel free to pause and give this one a shot. So both of these quantities have negative exponents, which means we're going to flip this whole thing. Let's take the 3x to the 4th, put it on the top of the fraction so that its power becomes positive. Let's take the 9x cubed and move it to the bottom so that its power becomes positive. Now, exponents before division, so power rule on the top, we're going to multiply these guys by 3. Power rule on the bottom, we're going to multiply these guys by 2. So we're going to have 3 cubed and then x to the 12th on the top. And then we're going to have 9 squared and x to the 6th on the bottom. Let's fix these coefficients. 3 cubed and 9 squared. Do we know how much 3 cubed is? 3 times 3 is 9 times another 3 is going to make this 27. And then 9 squared, 9 times 9 is going to make this 81. Okay, so now we're ready to do our division. So when we divide 27 by 81, it doesn't divide. If we try to divide 27 by 81, we get a decimal, and we definitely don't want to make decimal coefficients. That's just not proper. We just don't see that with polynomials. But we can have fraction coefficients. We just need to make sure our fractions are reduced. So 27 over 81 does reduce. Now, in Desmos it shows me the decimal, but you see in the blue here it looks like a little fraction that's being circled. If we just tap on that little circle, it's going to reduce the fraction for us. So 27 over 81 doesn't divide, but it does reduce. So our coefficient can be a fraction, just like if in the last one, 1 divided by 1 was 1, we could have a coefficient of 1, or where did we do some division here? Oh, I guess we didn't. Maybe on the front. Where did we do this? Okay, like this guy. Okay, we divided and we said 18 divided by 3 was going to make 6. We can have a whole number coefficient in the same way we can have a fraction for our coefficient. So 27 over 81 reduces to a third. So our coefficient is going to be 1/3. And then we're going to have x to the 12 minus the 6th, which is the 6th power. So 1/3 x to the 6th, or if you didn't want to make the fraction coefficient, if you wanted to leave the x's on one side of the fraction, where do they belong? Well, the 12 were on the top, the 6 were on the bottom. Those 6 x's, if we wanted to stick them on the top of the fraction with the 1, we could definitely do that. So it doesn't matter which way you write this, but you do have to recognize that x to the 6th over 3 is equivalent to 1/3 x to the 6th. So both are correct. I'm really okay with either one, but you do have to recognize that they're the same. Okay? So if you were taking, let's say, a multiple choice quiz and maybe the answer was given to you in this form, you'd have to recognize that it was equivalent to this one. Alright? Alright, I got one last one here. Again, feel free to pause and give this a try. So this one, we see hopefully some quotient rule inside the parentheses, and then here's our power rule. Which one should we do first? Well, following order of operations, it says if there's anything we can simplify inside the parentheses, we should do that first. So let's do that. Inside of the parentheses, we're going to use our quotient rule. We're going to divide and subtract. So inside the parentheses, 16 divided by 4 is going to be 4. And then we're going to have x to the 1 minus 1 is 0. We're going to have y to the 7 minus 1, which is 6. We're going to have z to the 5 minus 2, which is 3. And then all of that is being raised to the 3rd power. Okay? Now, before using my power rule, again, 0 rule is like the negative rule. It doesn't appear in our order of operations, so we can take care of that whenever we want. Anything to the power of 0 is 1. So if these 3 pieces, they're all just being multiplied by 1, then they're not going to change. So this x to the 0 is going to become a 1. Just means it's really going to go away here. We don't really need to multiply by 1. It doesn't affect anything. So I'm going to go and make this 4 y to the 6th, z to the 3rd to the 3rd. Okay? Now we can use our power rule. So let's multiply, multiply, multiply. That's going to give us 4 to the 1 times 3 is 3. Y to the 6 times 3 is 18. And z to the 3 times 3 is 9. And then one last step. 4 to the third power has a value. Again, you can use your calculator for this. 4 raised to the third power is going to be 64. So our final answer is going to be 64 y to the 18th power and z to the 9th power. And there it is. Okay, I don't think they'll get much more difficult than any of these that I'm showing you here, but I did put some in your practice assignment, so work through some of those, and if you find yourself struggling, just reach out. I'm here to help.